Hey, Matt Edwards here. I'm a doctoral candidate and research engineer at Madeli's Research Lab. And greetings from Lyon, France. Being annoyed by noisy neighbors is a problem that I think is shared by pretty much everyone across the globe. I personally have an upstairs neighbor with children, and I can often hear them rolling around their toys on the floor in the evenings, and that can be annoying from time to time. And this is just one example, as neighbors around the world have seemingly come up with ingenious ways of making all kinds of annoying noise. Where I live in France, most apartment buildings are made out of concrete, which is quite thick and heavy. And I've sometimes wondered why I could still hear my neighbors so easily, even with this thick, solid surface between us. Well, as it turns out, it has less to do with sound and more to do with vibration. I have here a speaker that works in a very particular way. You may have seen one of these before. When I turn it on, you hear almost nothing. However, as soon as I place it on the table, the sound all of a sudden is much louder. This device works not by being a speaker per se, but by turning the surface it's sitting on into a speaker. A normal speaker works by vibrating the air to create air pressure waves that we perceive as sound. And this speaker works not by vibrating the air directly, but by vibrating the surface it's attached to, which means it's literally turning the table surface into a giant speaker baffle. Hence the increased volume. So, what does this have to do with your neighbors? Well, the noise in your apartment works just about the same way. You're not hearing the sound waves from your neighbors that are moving through the air. You're hearing the sound waves that are moving through the structure too. In my case, when my neighbor's children roll their toys across the floor, they're shaking the floor itself, which essentially turns the ceiling of my apartment into a giant speaker, just like this device. Acousticians call this kind of noise structure-borne noise, and the techniques we use to reduce it are significantly different than those used for airborne noise. Airborne noise can be reduced by absorbing and blocking the sound waves as they go from one apartment to the other. But, just like this speaker, the best way to reduce the structure-borne noise is to physically decouple the two surfaces to stop the vibration from getting transferred. But when we're talking about building structures that still need to be load-bearing and long-lasting, it's not that simple. My personal research has to do with modeling indoor rolling noise, just like that which is generated by the rolling toys of my upstairs neighbors, as fate would have it. This is a kind of structure-borne noise which is very unique in nature, and I'm trying to find new ways to predict it so we can see which methods and materials work best at reducing it. Thanks. If you enjoyed this video, don't forget to check out the rest.
Good morning, Matt.
Good morning, Ray.
Where are you going to talk to us today?
I'm going to talk to you guys about building acoustics, specifically noise generated through the structure of buildings.
Great. And second question, who is the artist you wish you were, like as a musician? Like what would be your favorite artist that you would like to be?
I mean, the first thing that pops to my head is a musical artist, but I am more akin to the Broadway type, so I would want to be Adam Pascal.
Okay.
Yeah.
Great.